Take a circle of radius 1, add a point to the circumference of that circle, allow that point to rotate around the circle in an anti-clockwise direction. Now draw the radius to that point and drop the perpendicular from that point to the diameter. Now we will complete the triangle. So now you see we have generated a triangle from the radius rotating around the circle in an anti-clockwise direction. So let's pause the simulation and we will add in the angle theta, the x distance, the y height, and the radius r. The y distance is called the opposite because it's opposite the angle theta. The x distance is called the adjacent, and the r distance is called the hypotenuse. We will draw the vertical axis of the circle and shift it over to the right. Let the x-axis of our function be given by the angle theta. We have our height y and our radius r. The height of our function is given by the ratio of the y divided by r. In this instance, the radius of the circle r is 1, so we have y divided by 1, which is just the value of y. So the height of our function is the height y. Let's place the height y at the correct position along the theta axis. Now let's start off at a value of 0 degrees. Now we will work our way round the circle and we'll see the position of the y along the theta axis and also its height. So you can see here that the white line is moving along the theta axis. The height of the white line is the y value for our triangle. So let's put a trace on the function and we'll see what it looks like. So you can see the function in pink, and this is called the sine function. Now the sine function gives us the ratio of the y to the r of our triangle for each of the angles theta. We have generated the function f of theta is equal to sine theta, and this is given by the opposite over the hypotenuse, which is the y value over the r value for each of our angles theta. So let's move on in the next video and we'll look at the next function, which is the cosine function.